All right, so in this video, we're going to go through some examples and discover more about multiplicity. So this is number 1, and I've already graphed f of x equals x squared plus 10x plus 25. So I've already graphed that over here in Desmos. I just slid it over so that we can see both things at the same time. So this is the function x squared plus 10x plus 25, and I'm going to highlight where it crosses the x-axis. So it crosses the x-axis at -5, 0. So I'm going to keep that in our viewing screen here. So the things that you're going to be expected to know and label, I want you to tell me what the zeros are, tell me what the multiplicity is, tell me if that 0 crosses through the x-axis or if it bounces, tell me the degree, the y-intercept, the left end behavior, and the right end behavior. So we can tell all of that simply by graphing each function. So I've graphed this one, so let's say what the 0 is. There's only one 0 for this function where it crosses the x-axis, so that one 0 is -5. There are no other zeros. Now let's talk about multiplicity. Multiplicity is how many times does that factor count, how many times does that root count as a factor? Now I see that this bounces through where my cursor is moving over on the left side. This one is a bounce. If something bounces, it has to be an even number of multiplicity. So even though this only touches the x-axis once, this is a quadratic equation. So we need two solutions. One may be real, one may be imaginary, but I need an even number of solutions. So this has a multiplicity of 2. So it bounces through. Now we're going to say, I already said that one, it bounces. I've said that a few times. It bounces. Okay. So it doesn't go through the x-axis. It just touches, it turns the other direction, and it keeps right on going like when you bounce a basketball. Now our degree, if you add up your multiplicity, you can get your degree that way. Or you can just look at your function. My degree here is 2. Your y-intercept is where it crosses the x-axis. Let me come over here and move this. So you're going to plug in 0 for all your x's. So x squared plus 10x plus 25. You can plug in 0 for all your x's. I can do some mental math with this. That's going to cancel, and this is going to cancel. So you're going to be left with 25. But suppose you didn't know that, you can always let Desmos do the work for you. So when I type in, it's because I have multiple functions in here. Let me change this to Z, G, and H. Okay. So now when I plug in 0, notice I get 25 back. So what we're doing is taking 0, plugging it into the highlighted function here, and trying to figure out what the y-intercept is. The y-intercept is where it crosses the y-axis. You can get that from your graph as well. So the y-axis is 20, y-intercept is 25. All right, let's do end behavior. This is an even function, and it's going up. So end behavior on the left and right side is positive infinity. So not too many calculations going on there. Okay, not too many calculations. We just went through, I graphed it in Desmos. We were able to state the zeros, multiplicity, what type of multiplicity, and then all of those characteristics listed over there on the left-hand side. Okay, let's definitely go through and do another one. So this time we're going to be taking a look at f of x equals x to the 4th minus x to the 3rd minus 20x squared, and we're going to go through and list the characteristics. Now I've already graphed this one in Desmos, so let me get rid of this one, and we are now on this one. Okay, so this is what my function looks like when I graph number 2. I am going to go ahead and highlight my zeros. That's going to help me out. So I see there's one there, there's one there, and there's one there. So first column, list out your zeros. Our zeros, based off of the graph, I got one at -4. I got one at 0. And I got one at +5. So those are our 3 zeros. Now, this is x to the 4th. I can see that in my equation over here that my degree is x to the 4th. So I'm going to go ahead and label that this is x to the 4th. Multiplicity. If I look at -4 over here on Desmos, this one crosses through the x-axis. So where my cursor key here is, it passes through and it keeps right on going. So this one crosses. And since it's an odd number and it crosses, it has multiplicity of 1. If I take a look at 0, hopefully you notice 0 bounces. It goes up, it touches, and it comes right back down. There's no action where it goes up and over the x-axis. So this one bounces. So it has a 2 multiplicity. And we already said it bounces. And for 5, this one crosses. It goes up, 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 and it keeps going up. It crosses through the x-axis. So this one has multiplicity of 1, and it crosses. All right, so we filled in everything just based off of our graph. Now we can find the y-intercept. Again, you're taking 0 and plugging it in for all your x's to find your y-intercept. Little shortcut, I think some of you guys know, some of you guys do not, but if you just take 0 and plug it in, it'll tell you what your y-intercept is. So our y-intercept for this particular problem is 0, 0. So y-intercept is where it crosses the x-axis. And on my end behavior, so in behavior, both directions, looking over here at Desmos, the left-hand side is going up where my cursor key is, and my right-hand side is going up. So my end behavior for both of these is positive infinity. Okay, and just like that, we were able to label everything for this one just by looking at the graph. Okay, and let's take a look at one more. Oh, before we take a look at the last one, your multiplicity must add to your degree. So even though we only had 3 solutions, my degree up here is 4. So that tells me that something had to have multiplicity of more than 1. So it had to be this one because your bounce roots, they have an even number of multiplicity, and the ones that just cross, they have multiplicity of an odd number. So that's how I knew when I added these together, 1, 2, 3, 4, it had to match my degree. So that's just another clue to let you know that your multiplicity must add to be what your degree is. And the last one, and I'm skipping around a little bit, I'm looking at number 5 on my paper here. All right, and let me pull up the graph. I already have it graphed in here. Let me cut this off. Okay, so we're looking at this one in the green here. All right, so step 1, let's identify our zeros. So I got a point there, and I got a point there. So our zeros for this function are -3 and 2. Now, it's a few different ways you can get your multiplicity. Very fortunately for us, this equation, the way it's written, is already telling you the multiplicity. So x plus 3, you set it equal to 0, you get -3. Notice that's one of my roots here. And 3 is my exponent, so it has a multiplicity of 3. This x minus 2, you set it equal to 0, you get +2. That's where this root of +2 came from. And notice it is telling us that 2 is the multiplicity because that's my exponent up there. So if it's written out in factored form, it makes your life easier. You can just count the exponents and it tells you what your multiplicity is. This multiplicity is also going to give me my degree if I add it together. So 3 plus 2 also gives me a degree of 5. Now, let's see what it does at -3. At -3, hopefully you already see that this one crosses through the x-axis, so it crosses. And at +2, this is a bounce. It goes up, it touches, and then it comes back down. So this is a bounce. Let's identify what our y-intercept is. Again, you're taking 0 and plugging it in for all of your x's because a y-intercept is where your x is 0. But we can use a shortcut. We can let Desmos figure that out for us. I got -108. So the y-intercept is 0, -108. And I've already written that here. So 0, -108 is our y-intercept where my cursor's hovering around there. Last thing is we need to figure out the end behavior on the left side and end behavior on the right side. On the left side, this function is going up. So that's where we are here. It's going up, up, up. So my end behavior is positive. And on the right-hand side, this function is going down. Feel free to use your cursor keys and things over here in Desmos to zoom in and zoom out if you really wanted to be sure. But that function is going down on the right-hand side. So my end behavior is -infinity. So not too many calculations here. You're just looking at your function and trying to identify if it's going to cross or bounce at the x-axis, and then trying to identify what the multiplicity is. So now you are all ready to go do your Canvas assignment for today.